is assignment A100. In this script, model planetary objects with a planet class that computes positions based on an orbit parameters. It calculates distance between Earth and nearby planets over 1,000 days, simulating both exact and noisy measurement. Plot depicts how noise affects the distance data over the time. Average distance reveals the Venus are closest to Earth on the average. The code also constructs a matrix showing average distance among all the planets over the 1,000 years and computes the specific distance between Earth and Mars on day 732, providing insight into planetary dynamics and approximately within the solar system. Questions. What is the distance between Earth and Mars on day 732? On day 732, the distance between Earth and Mars is approximately 6.52 units. How do your position and distance function work? What trigonometry function do you need to use? The position function in the planet class computes the x and y coordinates of a planet on a given day in its orbit using trigonometry function mat.cos and mat.sin. It calculates the angle of the planet's position related to its orbital period, converting into a Cartesian coordinate based on its orbital radius. The distance between the planet function calculates the equivalent distance between two planets using the Cartesian coordinates derived from the position function. It utilizes the maths square to compute the square root and the maths power for squaring the difference in its coordinate, ensuring accurate distance and calculation based on the position in space. Briefly explain how you generated the 1,000-day time series and their average. Is there any periodic pattern available? In the noise case, does the average ranking change when S increases? Try to provide a reasoning for this observation. The 1,000 time series for a distance between Earth and Mercury, Venus, and Mars were generated by iterating through each day and computing both exact and noisy distance using the similar distance function. Averages were computed by summing the distance over the days and dividing by 1,000, relieving the uh, average approximately of each planet Earth. Periodic patterns are visible due to the planet's orbital period affecting the distance from Earth over time. In noisy cases, as the standard deviation of noise increases, the daily distance exhibits a greater variability around the exact values. However, the ranking of planet based on average distance remains generally consistent because noise affects all measurement similarity, maintaining relative proximity relationship determined by orbital mechanics other than noise level alone. How do you form 8 to 8 matrix and fill out the average of 1,000-year simulation? Check whether the closest planet to Earth is a different planet in this simulation. The 8 to 8 of average distance between the planet was formed by computing average distance between each pair of planets over 1,000 years using the average simulation distance. Each planet in this matrix represents the average distance between the two planets based on their orbital diamonds. In the summation, Venus remains the closest planet to Earth on the average as determined by comparing the average distance across all the planet pairs in the matrix. This result persists and despite the variation in distance due to orbital interaction and ref, uh, noise and reforming the Venus approximate to Earth in the solar system. Thank